All right, so now we're going to talk about dividing polynomials. We learned all about polynomials, but what we're really moving towards is understanding rational functions. And so with rational functions, of course, that's really just a polynomial over another polynomial. So we've got to look at how to divide polynomials before we can really talk about rational functions. So we're going to talk about long division for dividing polynomials and also synthetic division, which is a shortcut useful in a somewhat limited range of problems. And then we're going to talk about the evaluating polynomial using the remainder theorem. This is actually in chapter 5.5 in the book, but I think it's in the homework for 5.4. So, with factoring polynomials, if we can factor the polynomial, which we'll call p of x, we can really easily find the exact zeros. But if we can't, if it's a higher order, if it's a quadratic, great. We can factor quadratics pretty easily. If we can't, we have the quadratic formula. But if we have a cubic or fourth order or fifth order or whatever, it's getting really tricky. Okay, and there is a formula to find, like the quadratic formula for cubics. And I think there's one for fourth order polynomials, and it is like literally a mile long, just about. So we got to think of some options. So one option that we're going to talk about is long division. So this is just like arithmetic long division, which hopefully you guys learned. But just to remind y'all, like if we want to divide 247 by 3, we would say, okay, how many times does 3 go into 2? 0. So we'll move on to the next. How many times does 3 go into 24? We would say, great, 8. 8 times 3 is 24, so there's no remainder there. We're going to bring down the 7. How many times does 3 go into 7? 2 times. 2 times 3 is 6. Subtract. All right, we subtracted. We're subtracting. We get 1. So 1 is our remainder. And 82 is our, I believe, quotient. Okay? So if there's a remainder, then we know the number that we divided by, the divisor, is not a factor. So we're finding p of x, our polynomial, over d of x, which we're going to hope is our factor. Okay, so we want to find, we're aiming to do polynomial division. We're trying to find p of x over d of x, where p of x and d of x are both polynomials. Before you do anything, you need to make sure those polynomials are in standard form, which means highest power first, and then in order of descending powers, okay, from there. And also really important is that you fill in any missing powers with zeros. These are going to be our placeholders. Just like if you have a number, 107 means 100, let's make it 207, right? It means 2 100s, 0 10s, and 7 1s, right? So we need, if you don't have an x squared term in there and it's fourth order, you need to say 0x squared. And then we are going to do this division until the remainder gets down to 0, or it has a degree that is less than that of the divisor. And of course, you can check your work, not that anybody really does, by taking the divisor times the quotient, which is your answer from your division problem, and add into the remainder, and that should give you what you started with, right? So p of x should equal your divisor, the d of x, times your quotient, q of x, plus your remainder, r of x. So the algorithm is here, and it's a long one, right? And it's going to be like, whatever, just show me an example, which we're going to do in the next video. So you're going to set up your division problem. You're going to determine the first term of your quotient. Remember, your quotient is your answer. We're going to think of it that way, right? by dividing the leading term of the dividend by the leading term of the divisor. So whatever that is the first part of your answer. Then you're going to multiply that by the divisor and write it below, below the like terms in the dividend. Do the subtraction. This is really just like what we did with dividing 247 by 3, right? Bring down the next term of the dividend. Repeat your steps 2 through 5 until you get to the last term of the dividend, and then you express your remainder. So since we're at the 5.5 minute mark, let's pause this and we're going to start with some examples in the next videos.